Hey everyone, welcome back to my channel. I'm Neil and today we're diving into part 3 of coordinate geometry. Before we jump in, make sure to subscribe so you don't miss any of my upcoming videos on this topic. Okay, without further ado, let's get started. In the previous session, we talked about gradient or a slope of any straight line, and I'm gonna go further on this topic. Okay, we have a point 5 and 2 that lies on a line with gradient -2/3, and I'm gonna sketch this line. Okay, first of all, I'm gonna plot this point. Let's call this point A, which is 5, 1, 2, 3, 4, 5 as x coordinate, and y coordinate is 2, 1 and 2. So this is point A. And now the gradient is -2/3. We know that the definition of gradient is y step or difference of y's of 2 points which are lies on a straight line over x step or difference of x's. So -2 is difference of y's and 3 is difference of x's. So I'm gonna move 3 units to the right. So 1, 2, 3, +3, and then go 2 units down, 1 and 2, -2, and this is the point that we are looking for. Okay, point B, and now I'm gonna draw a line that passing through these 2 points. Okay, so this is line D. So we can use the gradient of any straight line and just 1 point to sketch that line. Okay. And now I'm going to talk about collinear points, what they are. Collinear points. Collinear points, 3 or more points are collinear if they lie on the same straight line. For example, we have a straight line like this, and some points like A, B, and C. All of them lie on this line, line D. So we can use point A and B for find the gradient of AB, or use point B and C for finding the gradient of BC, or even using A and C for finding the gradient of AC. And in all of these 3 cases, the gradient is exactly the same. So gradient of AB equals gradient of BC equals gradient of AC, because we have only one straight line and all of these points lie on this straight line. So we are going to use this fact for solving some challenging question. For example, we are given that point A is 3 and -2, B is -1 and 10, and C is 4 and M, which is an unknown. And we know that they are collinear points, so we are looking for the value of M. Okay, so they are collinear points. So in this case, we know that the gradient of AB is the difference of y's, so -2 minus 10 over difference of x's, 3 minus -1. So we have -12 over 4. So the gradient is negative 3. And now I'm going to find the gradient of BC. So this was AB. And then the gradient of BC is difference of y's 10 minus m over difference of x's, negative 1 minus 4. So we have 10 minus m over negative 5. And we know that because they are collinear points, so the gradient of AB should be equal to gradient of BC. So we have an equation, negative 3 is 10 minus m over negative 5, and we just need to solve for m in this equation. So we can use cross multiplication. Negative 3 times negative 5 equals 1 times 10 minus m. And I'm going to simplify this to this, and m is 10 minus 15, which is negative 5. Okay, so far so good. And the next topic is parallel lines. For example, we have two lines, and these two lines are parallel, D1 and D2. If two lines are parallel, then they have equal gradient. In fact, the gradient of D1 equals to gradient of D2. Or conversely, if the gradient of two lines are equal, it means that these two lines are parallel. Okay, as an example, we have 2 points, A and B, and the line joining these 2 points A and B is parallel to a line with gradient negative 2. So the question is, we have 2 points A and B which lie on line D, and the line D is parallel to D prime, and the gradient of D prime is negative 2. And now we are going to find the value of alpha. Okay, so the first thing that I'm going to do is to find the gradient of line D using these 2 points, A and B. So the difference of y's 3 minus negative 1 over the difference of x's 2 minus alpha, which gives us 4 over 2 minus alpha. And we know that the gradient of D prime is negative 2, and these two have equal gradient. So 4 over 2 minus alpha should be negative 2. So we have an equation and we should solve for alpha. So I'm going to use cross multiplication. 4 times 1 is 4, and negative 2 times 2 minus alpha, we should use distributive law. 4 equals negative 4 plus 2 alpha. So add 4 to both sides of the equation. So 2 alpha is 8, and divide both sides by 2 gives us alpha is 4. If I want to check my answer, so the alpha is, we found that 4. So this is 4. We just need to substitute 4 here and now find the gradient of AB. So the gradient of AB is difference of y's negative 1 minus 3, the difference of x's 4 minus 2. So we have negative 4 over 2. So the gradient is negative 2. And the gradient of d prime was negative 2 as well. So you can see that these are equal because they are parallel. So we did it completely correct. Okay, so it was about parallel lines. And now we're going to dive into perpendicular lines. We have two lines. The first one is this. We can call this line D, and the second one is this one. We can call this D prime. And these two lines are perpendicular. If two lines are perpendicular, then their gradient are negative reciprocals. So the gradient of D is negative reciprocal of gradient of D prime because they are perpendicular. So and conversely, if we have two lines that their gradients are negative reciprocal, so we can find that these two lines are perpendicular. So you can write this in another form if you consider the denominator 1. So if you use cross multiplication and multiply gradient of d by gradient of d prime, so the answer is negative 1. So gradient of d times the gradient of d prime is negative 1. So if we have two perpendicular lines, the product of these two gradients equals negative 1. And you can use either of these formula to solve some challenging question. For example, we have 2 points, negative 1 and negative 3, and 1 and t. And these 2 points lie on line D. And we know that line D is perpendicular to D prime, and the gradient of D prime is 2. And we are looking for the value of t. This is the question. Okay, the first thing is to find the gradient of D using these 2 points. So difference of y is t minus negative 3 over difference of x's 1 minus negative 1. So t plus 3 over 2 is the gradient of D. And we know that these two lines are perpendicular. So the product of line D, gradient of line D and D prime should be negative 1. So I'm going to use, this one. The gradient of D is t plus 3 over 2 multiplied by gradient of D prime is negative 1. And the gradient of D prime is 2. I'm going to substitute this, 2. Okay, so t plus 3, these two cancel out, equals negative 1. So t is negative 1 minus 3 is negative 4. Our final answer. And I'm going to check my answer. So t is negative 4, so we just need to substitute here negative 4. Negative 4 plus 3 is negative 1 over 2. So the gradient of D is negative 1 over 2. And we know that the gradient of D prime is positive 2. So you can see that negative 1 over 2 is negative reciprocal of positive 2. You just need to flip 1 over 2, which is 2, and change negative to positive. So we solve this question correct. Okay. And now for better understanding, I'm gonna cover another example. We have a point which is S with coordinates S and 8 and lies on a semicircle. So this is a semicircle as shown. And we are looking for the value of S. Okay. First of all, we know that this is the origin of X and Y plate and the coordinates is 0 and 0. For finding the value of S, first of all, I'm gonna find the distance between O and Q. In fact, this is the radius of this semicircle. We can use a formula for finding the distance of O and Q, but it's really easy. The radius is 10. Okay, so this is the radius. And now this is the radius. And now we know that OS is radius as well. So I'm gonna write that OS equals 10. But I'm gonna use formula to find OS because we have an unknown here, which is S. Okay, the formula is OS equals square root of difference of x's s minus 0 squared plus difference of y's 8 minus 0 squared. And OS is 10, so I'm gonna substitute 10 here. S minus 0 is S, so S squared. 8 minus 0 is 8. 8 squared is 64. So I'm gonna find the square of both sides of the equation. So 10 to the power 2 is 100, and we get rid of the square root. So S squared plus 64. So S squared is 100 minus 64 is 36, and S is positive and negative 6. But because we have in the quarter 1, the first quarter, so S is positive 6 is accepted, and S is not negative 6 because in the first quadrant both X and Y are positive. So X is not allowed to be negative 6. Okay? So we find the value of S, which is positive 6. Okay. Positive 6. Okay. For part B, we are going to find the slope of PS. Whereas PS is here. I'm going to draw a line, PS. Okay. And find the gradient or the slope of that. The gradient of PS is difference of y's. So y is 8 and y is 0. So 8 minus 0 over difference of x's. S, which is 6 minus negative 10. So 8 over 16 is 1/2 the gradient of PS. And then finding the gradient of SQ. Where is SQ? Here. So I'm gonna draw another line that passing through S and Q, this line. So the gradient of SQ, difference of y's, 0 minus 8 over the gradient, the difference of x's, 10 minus 6. Which is negative 8 over 4, and the answer is negative 2, the gradient of SQ. And for the third part, we are going to use this fact, the answer of part B, to show that angle PSQ, where is PSQ, is here. Oh, sorry, angle, not triangle. PSQ. PSQ is a right angle, which means here. It's completely correct. Why? Because PS has gradient 1/2 and SQ has gradient -2, and 1/2 and -2 are negative reciprocal, or when you multiply 1/2 by -2, the answer is -1, and this is the condition when we have two perpendicular lines, and you can see that these two lines, PS and SQ, are perpendicular, and this angle, angle S, is gonna be a right angle. So I'm gonna write that because the gradient of PS is negative reciprocal of gradient of SQ, so PS is perpendicular to SQ, and we found that S is gonna be a right angle, which is 90 degrees. I hope you enjoyed this video. See you in the next one. Bye bye.